Okay. So basically, what I have to work on right now is um, verbalizing quadratic.
Okay.
So the first one is 3D squared, or yeah, 3D squared.
3z squared.
Yes,
Okay.
equals 10 minus 13z.
Okay. When you have a quadratic that has a squared term, a non-squared term, and a number, you always do one thing with it. What is that?
Do you square root it?
No, that's not going to work. Notice that we would not want to take the square root of 10 minus 13z. That's very complicated. Okay?
Right.
Put it all on one side. And
Oh, right.
the
You
other
get to take
side
it.
is equal to 0. That is the key. Put it in order. Having this 0 is hugely important. And the reason is that if we factor this quadratic into two things times each other, well, if you get two things times each other equals 0, well, then you can state that one of them has to be 0. Okay, whereas if you have two things times each other equal to some number, you can't state anything. So it's a huge principle in algebra that if you get a certain number of things multiplied together and they're equal to 0, that's huge because you can figure out what each thing is. Now, how do I factor that?
Right. Um, Factoring. Okay, that's the kind of the hard part because you have to get the like 3z squared involved, right?
Yeah, they teach various factoring methods around the state. Some call it the California method, some call it the diamond method. They're all trial and error, okay? So I actually hate both of those methods. I think they're confusing, they're complex, it's hard to remember. Here's my method. You start by splitting up the z squared term. Well, there's only one way to split that up, like that. Okay?
Okay.
Now, the next thing you do is determine both sides. Well, the only way you can produce a minus 10 is if you have a plus and a minus, or a minus and a plus. And I write it like that because it's different. In other words,
Right.
if it was z and z, then it's all I would have to write is plus minus, because the other would be the same. But in this case, because one coefficient is 3 and the other coefficient is 1, well, these are all going to give different answers. Now, factors of 10. Let's list them. What are they? There's two of them.
5 and 2.
And that's it. Okay? Now, what I tell everybody is always start with the two factors that are closest together when you're doing a trial and error process. Okay? So I'm going to start with 5 there and 2 there. And I basically am going to have four choices. I can do 5 there and 2 there, or I can do 2 there and 5 there, or I can move them down one and do those same two things. And the whole point is to produce a middle term of 13z. Well, what middle term would this produce?
Um, oh, right. That would
The
be,
middle term always comes from the inside and the outside. Just multiply the inside
okay,
two terms together, the outside two terms together, add them together. That gives you minus 1z, right?
right.
Not only is that wrong, but it also tells us that there's no point in trying the 5 with the negative sign and the 2 with the positive sign, because it gives you the same number, it just gives you a different sign. That would give you a positive 1z if I did it the other way. So that eliminates a lot of choices, okay? So I know it's not 5 here and 2 there, or 5 there and 2 there. So let's try another one. Let's try 2 here and 5 there. What middle term does that produce?
Um, that produces 13.
Negative 13z. Well,
Oh,
that's close. That's a lot of our answer. It's just the wrong sign. So how
so
do
just
we get,
switch the
yeah,
signs.
put the 2 down there, the 5 over here, erase everything else that we have written like that and like that. And that is going to produce the middle term that we seek, which is minus 2z plus 15z, which adds to 13z. I call this my double smiley face method. Okay? And it works just as well as the California method or the diamond method. In fact, I think it works better. Particularly, these are kind of second degree quadratics, meaning factoring these are a little more difficult than first degree quadratics. Merely if you ever have a number other than 1 there, then it's going to be a little more difficult to factor than it would normally be. If this is a 1, then it's really simple factoring. Okay, and that's the only thing I call first degree or second degree, is how complicated or simple it might be to factor. Okay, now I still haven't quite solved it. I know that this number times this number is equal to 0. So what's the next step in solving it?
Um, do you FOIL it out?
No, we just unfoiled it. That's what factoring is unfoiling. In other words, you're taking a quadratic that started with that linear term times that linear term.
So you probably combine like terms.
No, here's the deal.
No.
This might be the most important concept in algebra. I've got that quantity times that quantity, and it multiplies to be 0. Well, that tells me two things. That 3z minus 2 could be equal to 0, or z plus 5 can be equal to 0. One of those has to be true. And what we assume is that both of them are true. Well, if I solve this equation here, I get z equal 2/3. And if I solve this equation, I get z equal minus 5. So those are your two solutions. If you take either of those solutions and plug it back into your original formula or original equation, you will see that it works. Both of them will be true. Now, occasionally you have quadratics that produce two solutions, and one of them is called extraneous. It's not true, but that's fine. The rule of algebra says that the only thing that has to be true is that one of these two things has to be 0. Either that one or that one. It's the only way you can produce this 0 over here. You can't think of two numbers that multiply together that are equal to 0 unless one of them is 0. Okay? So that's the essence of solving quadratics, is putting everything on one side and setting the other side to 0. Now, it's a little different if say you did not have the z term. Let's say I had something like that, okay? Well, now I don't need to do it the other way. In other words, I don't need to set everything on one side and set the other to 0. I can solve this by taking the square root of both sides. And then, of course, I have to simplify that. No, I don't. That's not simplifiable. So that's my answer. So it kind of depends on the nature of your quadratic, whether you have the squared term, also a non-squared term, and a constant. If you do, then you always want to do it where you put everything on one side and 0 on the other. What else do you have?
Well, there's one that says find the value of x for each of the following figures. There's a triangle. And then in the middle of the triangle, with like a dotted line going down, it's x plus 3. And then the bottom of the triangle is 2x plus 8. And then it says a equals 42.
What's the bottom of the triangle again?
2x plus 8.
Okay. A is the area. Okay. So what is area? What is, you know, almost every math problem should start with the general formula. I don't care if it's a geometry problem, an algebra problem, or a calculus problem. You want to start every single problem with a general formula. What's the formula for the area of a triangle?
Base times height divided by 2.
Yeah, I like to think of it as 1/2 base times height. Okay, so let's plug those in. What's the base?
2x plus 8.
What's the height?
X plus 3.
Now let's multiply that out. Now here's where we have to FOIL, and we know the area is 42. Okay?
Okay.
So let's multiply that. It's probably easiest, in this particular problem, it's easiest to multiply the 1/2 times the 2x plus 8 first, right? Because that gives you x plus 4 times x plus 3. In other words, we got rid of our denominator and we made the FOILing process easier. Now multiply those two together for me. FOIL them.
So that's x squared plus 3x plus 4x plus 12.
Okay. So, hold on. So now simplifying everything. What do I do with that 42?
Do you get it on the same side?
Right. In other words, I want 0 on one side. So I'm going to subtract 42 from both sides. Okay? Now, this is what I call a level 1 quadratic in terms of difficulty, because the x squared term has a 1 as its coefficient. So with these, you really can come up with some really simple rules. It's not so much a trial and error process. The first step is to separate the x's. Second step, determine both signs. What are both signs here?
One of them is positive and one of them is negative.
And it doesn't matter in this case whether I put the negative on the left or on the right. Because the coefficient of the x's are both 1, well then I don't need to allow for either or like I did in the last problem. Now, the third step, Really rather simple. Factors of 30 that subtract, because of that sign right there, to the number 7. Well, what factors of 30 subtract to 7?
Well, there's 10 and 3.
Ah, perfect. Now, where does the 10 go and where does the 3 go?
Um, it'll be the x plus 10 and then x minus.
Yeah, the larger of your two factors that you found goes with the sign of the middle term, which in this case is positive, so the 10 goes there, the 3 goes there. And it's always a good idea to check to make sure that those two multiply together to give you that, but you really don't have to do the entire FOIL. In other words, we know that x times x is x squared, and we know that plus 10 times minus 3 is minus 30. So the only term that really can get off on us is the middle term. So again, I'm going to use the smiley faces, add them together. That's our middle term. We did it correctly. Now, what's the answer? In other words, they want you to solve for x.
Right.
So what's the next step? This is all equal to 0.
Right. Then, I don't.
If I tell you that A times B times C times D times E equals 0, there's only one way that can be true.
Oh, right. Okay, so.
One of these is 0. So
right.
that's the approach you take, is start setting these to be 0. So if x plus 10 equals 0, or x minus 3 equals 0, now solve each one of those. So what are my two solutions?
Negative 10, and then one of them is positive 3.
Yeah. And you generally, when you have quadratics, you expect two solutions. Okay, most quadratics will have two solutions. Cubics will have 3 solutions. Quartics will have 4 solutions. Linear has 1 solution. If I have x minus 3 equals 0, then x equals 3. One solution only. So when you have a quadratic, always look for 2 solutions. And that trips people up sometimes. If I gave you this problem, what's x equal to?
X is equal to 2.
No, x is equal, remember you're looking for 2 solutions.
Oh.
Plus or minus.
Oh, positive.
Yeah, notice that minus 2 times minus 2 is equal to 4. So both of those solutions work. Okay. Now, I also like to tell people that if you're ever solving an equation where you have to take the square root of both sides, always start your answer out with plus or minus. It doesn't matter what number I have over here or anything else. If I'm solving it by doing this, then my answer starts out plus or minus. And just, there's another way to do this problem which may be better. Let's subtract 4 from both sides. In other words, let's take the same strategy that we take with most quadratics. We're just going to set it equal to 0. Well, what's that called? That's difference of perfect squares, right?
Yes.
How's it factor?
Oh, would it be x?
X minus 2, x plus 2, always, whenever you have difference of perfect squares. And now notice that you cannot make the mistake that it's easy to make with the first one. In other words, we get our two solutions by setting both of these equal to 0. So there's our two solutions. And in other words, by setting it equal to 0 and turning it into difference of perfect squares, it forced us not to make an error. The standard error that everybody makes here, which is to say x equals 2, which isn't correct. But if I move the 4 over and turn it into difference of perfect squares, now I'm guaranteed to get x equal 2 and x equal minus 2. All right, what other problems do you have, Anna?
Let's see. Oh, this one was hard. Okay, it's in parentheses.
I'm sorry, I didn't hear that last statement. Matter of fact, it sounds almost like I lost audio. You still there, Anna? Anna, I cannot hear you. I'm going to call you on the phone, and we can finish the audio by way of phone.
Hi, sorry, my computer died.
Okay, that's okay. Yeah, I just noticed it just now said offline. We only have 5 minutes. We can probably do it by phone. What's the next problem you have?
It's in parentheses m minus 3, and then parentheses squared equals 64.
Equals 54?
64.
Okay. So write that equation on a piece of paper. M minus 3 quantity squared equals 64. So now what's the next step to solving this?
Well, it's both squared, so you should probably write m minus 3 twice, right?
No, you don't need to. Usually when you see something squared and it's all by itself on one side of the equation, then you want to take the square root of both sides. Okay. If I take the square root of the left side, I'll be left with m minus 3.
Oh, okay.
What do I get when I take the square root of the right side? What's the square root of 64?
Oh, 8.
Plus or minus 8.
Oh, right.
Don't forget, remember, whenever you solve an equation by taking the square root of both sides, begin your answer with plus or minus. So now I'm looking at m minus 3 equals plus or minus 8. So we started with a quadratic. We would expect two solutions. What are my two solutions?
Would it be... So it'll be, one will be x equals minus 8, right?
No, I'm going to have to move this minus 3 to the other side. So I'm going to add 3 to both sides. So one solution is going to be plus 8 plus 3, which is plus 11.
Okay.
And the other solution is going to be minus 8 plus 3, which is minus 5. So my two solutions are 11 and minus 5. And notice how both of those work. If I plug in 11 for m, I get 11 minus 3 is 8. 8 squared is 64. That works. If I plug in minus 5 for m, I get minus 5 minus 3. That's minus 8. Square that, I get positive 64.
Okay.
So Usually when you have a quadratic and you come up with two solutions, you want to check both solutions. The thing is that you can spend a lot of time, wasting a lot of time if you're taking a test, checking when you don't really need to be checking. There are certain types of equations that tend to produce what I call these extraneous solutions. And those are equations that have radical signs in them, or absolute value signs, or logs. If you have just a regular polynomial, which is what you've been giving me today, normal polynomials, not so much do you find extraneous solutions. And you don't really need to spend the time checking both solutions unless the instructions on the exam say, show your work and check both solutions. Then, of course, you need to plug them back in, make sure that they are valid equations. But typically, what's going to produce what I call an extraneous solution are those three other things: radical signs, absolute values where you have a bar and the vertical bars, and logs. If you don't see one of those three things, then you probably aren't going to have extraneous solutions. You don't need to spend the time checking for them.
Okay.
Okay. All right, Anna, let's see, I have your brother in a half an hour, right? Nick, now, is he going to use the same computer?
Yes.
Okay. Did you reboot your computer, or did?
Yes.
Okay, I was going to say you might want to reboot it for him, just so it'll be ready, because that's almost always the first thing you want to try when something like that happens is reboot your computer, but that takes a while. All right, I will call Nick. I will send him the meeting ID on his cell phone, and I'll talk to him in a half an hour.
Okay.
All right. Thanks.
All right. Thank you.
Bye-bye.